L from this is only 50 from it is showing actually it is 0. From 0 you go up to 100. This is the actual gamut, not that circle. You got it. Look, consider this as a three-dimensional picture. This is the actual visual gamut, that is what a printing machine can do. But you see what a human can do. You see the difference. What a human can see the gamut and what a printing machine can do. This is the biggest limitation of any color generating system. I will show you a real MATLAB model. This is the actual MATLAB model for a stylus of the human visual system. This is the actual color model. So it is not exactly a scale. The sphere was only for you to learn it academically. You can see that. It's not an actual spherical shape or not a cylindrical shape, but it's a little different shape, just like this. The same thing, which is the same shape, which is plotted with that. Now we will come back to that. So I was talking about color deviation, how it happens. You see, this is the actual value and this is the set value. So the difference in space is where you move. It's called the delta E. I mean, it's the color deviation. So earlier days, it was calculated just by a Pythagoras formula, because there are L, A and B. So they use only delta E is equal to root of L square plus root of A square plus B square. That's the way they used to calculate it. Only to find out the hypotenuse size. That's the easiest way. But later scientists realized that that formula will not work. The reason is, by doing that way, you get only a mathematical number of the difference. Just imagine, I have lightness, I have A, I have B. By doing a Pythagoras rule, I can get a mathematical number 3. The same 3 I can get by varying only lightness, or only varying A, or only varying B. Okay. Number will be same, but the color appearance will be different. So keeping this in mind, now the delta E equations have changed a lot. Now the latest is CMC 2000. The latest one, what is in use is CMC 2000. So all the scientists, they are keep on reinventing, modifying it, making it more perfect. So you have the option in your spectrophotometer, which equation you are following. So CMC 2000 is the latest one, which they use, which will give you a more appropriate value in calculating. And you see the delta E variation. We say if the delta E variation between 0 and 1 is not much visible for a human eye.
Most offset printers are printing their own. They use 2 or 3 different types of paper, the most common type of the ink, and then they produce such a color guide. And this is then representing everything what the printer using a certain type of paper and our offset inks can achieve. And if you design something, then you can go into this, and if you want to have a dedicated blue, then you can select it here, and then you know exactly what you get. It will give you also the composition, whether it is 80% magenta, 70% cyan, and 50% yellow. So this is a very systematic one, and it is actually available, and you should ask for this type of guides. Otherwise, you will never communicate on the real basis with your printer. That can also be measured with a spectrophotometer. Here you have the YMCK values. Let's say if you have a gray or if you have a dark blue, so you know exactly what the composition is, maybe 100% cyan, 60% yellow, 70% magenta. This is then the composition you can read out of the book. With that you communicate with your printer. You can also use a spectrophotometer.